Hello. All right. So this is lesson 6D. So this is going to be dividing polynomials by long division. So we are going to be referencing back to kind of what we did in 6C. So we're pretty much undoing what we did in 6C. So instead of multiplying, now we're dividing. So I'm going to get you guys reacquainted with some of the terminology. So a polynomial is just a sum or difference of monomials, which you hopefully should remember from 6C. So from long division, we're also going to look at these four terms. So a dividend, a divisor, a quotient, and a remainder. So the dividend is the number, or in this case, the expression that is going to be divided. So the divisor is going to be the value or the expression which we are dividing by. So the quotient is the answer or the result, and then the remainder is anything that may be left over. So we're going to kind of review just long division in general and just the general process. So we have 3,248 divided by 4. So the dividend is always the first number, and then the divisor is the second number. So whenever we're doing our long division method, we're using our little house that somewhat looks like a square root, not really. So I'm going to write the 3,200, that's not a 3, 3,248, write that on the inside, and then I'm going to write the 4 on the outside. So if you ever need help like remembering, just remember the dividend is inside, dividend side. That's how I remember it. All right. So we're going to do some long division. All right. So you're going to look at 4 and see how many times it goes into 3. It doesn't go into 3, which means that we have to look at the next digit. So instead of just looking at 3, now we're looking at 32. So 4 goes into 32 exactly 8 times. So now what I'm going to do is I'm going to multiply 4 times 8, which gives me 32. And then I want to subtract to see if I get anything left over, which I don't. So we have a remainder here of 0. Now for the next step, now you want to bring down. So we're going to bring down that 4. And now we're going to repeat the same process. So 4 times what number gives you 4? Well, 4 times 1 gives you 4. So 4 times 1 gives you 4. So now we're going to subtract. And then start the process over again. So now I'm going to bring down the 8. All right. So 4 goes into 8 exactly 2 times. So now 4 times 2 gives you 8. And now I want to subtract. So there's no other numbers to bring down, which means our final answer, which is our quotient, is going to be 812. So we don't have a remainder in this case. All right. So we're going to follow the same process for polynomials. It is going to be a little bit more in-depth. So what I can say is whenever we're dividing by a monomial, so just one single term, you can just do your exponent rules, which is the quotient property, which is what we covered in 6b. All right, so looking at this very first one, I want to do 25x to the 4th divided by 5x. So just do your quotient property. So 25x to the 4th over 5x. So I'm going to have 25 over 5, and then I'm going to do x to the 4 minus 1, so quotient property. So 25 divided by 5 gives you 5, and then 4 minus 1 gives you x to the 3rd power. So 5x cubed is our quotient here. All right. So similarly over here for number 2, now we have a trinomial divided by the monomial. So what this is going to look like is I'm going to write every single term of the trinomial, or of the first polynomial. I'm going to write all of these out in the numerator. And then the denominator is going to be my divisor. So I'm going to write 4m cubed for the denominator for each of these terms. And then I'm going to simplify. So for the first one, we're going to have 12 divided by 4, which is 3. Then I'm going to have 7 minus 3. Then plus 16 over 4, which gives you 4. Then m to the 5 minus 3. Then minus 1/4 m to the 1 minus 3. So notice how over here, we don't have a number in the top to compare the 4 with, so we just assume there's a 1. All right, so I'm going to simplify. So I have 3m to the 7th plus 4m squared minus 1/4 m to the negative 2, which means I need to get rid of that negative exponent. So 3m to the 7th plus 4m squared minus 1 over 4m squared. All right, so that would be our simplified quotient. All right, so that was dividing by a monomial. Now I want to divide by a binomial. So whenever we're doing division by a binomial or trinomial or anything that's more than one term, we have to do long division. All right, so there is another way that you can do these. It's called synthetic division, but you won't learn those until you get to Algebra 2. All right, so remember the first polynomial here is going to go on the inside. So I'm going to focus on the setup first. So 3n squared plus 13n plus 12. That's going to be divided by n plus 3. All right, so I'm going to do each step in a different color, just very similarly to how I did this up here. So anytime I change colors, it signifies a new set of steps. All right, so for these, you only want to look at the leading term. So when I say leading term, I mean look at n and 3n squared. So we want to find n times what value gives you 3n squared. So I'm going to kind of write this off to the side. So n times what gives you 3n squared? Well, that would be 3n. So that 3n is what I'm going to write on the top. So I'm going to have 3n on the top. So now what I want to do is I want to multiply 3n times n plus 3, and I want to write it underneath right here. So I'm going to do 3n times n. That gives you 3n squared. No. Oh my gosh. There. So we're going to have 3n squared, and then 3n times 3, which gives you 9n. So what you have to remember to do here is we're subtracting this, so you have to put it in parentheses. So this is kind of a tricky part right here. So we're going to do 3n squared minus 3n squared. So that just gives you nothing. So that's 0. Those 0 out. Your first set of terms here should 0 out. Your second set here, we're going to have 13n minus 9n. So I'm going to do 13n minus 9n. So that's going to give you 4n. All right, so that's going to be what's written here. So that's the first step. So now I'm going to write out the second step. So to begin that, you bring down the 12. All right, so same thing as before. I'm going to do n times some value to give you 4n. N times some value to give you 4n. All right, so what that's going to be is just 4. So I'm going to do plus 4 up here. All right, so now I'm going to take this 4 and multiply it times n plus 3. So I'm going to have 4 times n, which gives you 4n, and then 4 times 3, which gives you 12. and then I'm going to subtract. So notice how when I subtract, it's all going to zero out. So we're not going to have any remainder or anything. 4n minus 4n, 0. 12 minus 12, 0. So we have nothing left. So our quotient here, our answer, is that 3n plus 4 right at the top. So 3n plus 4. This is our quotient. All right, so before I continue, I want to just kind of point out this lesson is going to be challenging. It's going to be a little bit more rigorous. This is one of those topics you just have to keep practicing and keep pushing through in order to understand. You have to keep practicing. It's going to be a lot of patience. You're going to need a lot of patience for this one. All right, so moving on to the next one. So same idea. So 20m squared minus 3m minus 35 and 4m plus 5. All right, so remember, we're looking at the leading coefficients first. So 4m to get to 20m squared, and we want to figure out what do I multiply by. So 4m times what gives you 20m squared. So that will be 5m. All right, so that 5m, that's what I'm going to write up here. So now I'm going to take that 5m, and I'm going to multiply it times 4m plus 5 to write underneath. So 5m times 4m gives me 20m squared, and then 5m times 5 gives me 25m. All right, and then I'm going to subtract. All right, so the 20m squared minus 20m squared, that's just gone. So I have negative 3m minus 25m, which is going to give you negative 28m. All right, so that's going to be written underneath. So that's the first round. So I'm going to go ahead and bring down that 35, or negative 35. All right, so I'm going to do 4m times what value gives you negative 28m. So 4m times what value gives you negative 28m? Well, that value is negative 7. So minus 7 here. So now I'm going to do negative 7 times 4m plus 5, and that's what I'm going to write underneath right here. So negative 7 times 4m, which is negative 28m. Then negative 7 times positive 5, which is negative 35. Then you want to subtract. All right, so negative 28 minus negative 28m, 0. Negative 35 minus negative 35, 0. So we have no remainder. All right, so your answer here, 5m minus 7. Hello? I don't know what just happened. Notability just quit. Oh, it's gonna make me rewrite everything. How dare you? All right, anyways. So 4m times what value gives you negative 28m, which is negative 7. So negative 28m minus 35, subtract, and you get 0. All right. So if at any point during this lesson you start getting super like overwhelmed and frustrated, just take a break, pause. This is one of those lessons you really want to pace yourself. All right, so these are the general guidelines of this process, and my brain stopped working, of this idea, of this concept. All right, so we're going to get into some special cases, because tragically there are special cases, as if this wasn't more difficult as it is. All right, so the first quote unquote special case is really just if you have to reorder. So all the polynomials have to be in descending order. So they have to be from the highest degree to the lowest degree, which means your first polynomial here, you just have to rearrange it. So if I rearrange, that would be 4g squared minus 10g minus 1, and then divided by 2g minus 3. So really, this is the problem I'm working with. But once you do the reordering, then it's the same as pretty much any other problem that we just did. All right, so I have 4g squared minus 10g minus 1 and 2g minus 3. Okay. So for this one, once again, we're going to start with the leading term. So 2g times what gives you 4g squared? All right, so right off to the side. Oh my gosh. So 2g times what gives you 4g squared? Well, that would be 2g. So that's going to be what you write up here. All right. So now I want to do 2g times 2g minus 3. So I'm going to have 2g times 2g, which is 4g squared, and then 2g times negative 3, which is negative 6g. All right, so 4g squared minus 4g squared is 0, so those 0 out. Now I'm going to have negative 10g minus negative 6g. All right, so that's going to turn into plus a positive. So you're going to have negative 10 plus 6, which is negative 4g. All right. Now, I can bring down the 1, or negative 1. So I'm going to do the same idea. So 2g times what value gives you negative 4g? So the g is already there, so you just have to multiply by a negative 2. So in this case, I'm going to write negative 2 at the very top. And I'm going to do negative 2 times 2g minus 3 and write it underneath right here. So I'm going to have negative 4g. Then negative 2 times negative 3 gives you positive 6. So if you notice here, they're not going to completely zero out this time. So I'm going to have 1 minus 6, which gives you negative 5. So in this case, this value is going to be a remainder. So there's a very specific way in which you write the remainder for these problems. So your answer for these is going to be the quotient plus your remainder. And your remainder is written as the remainder divided by the divisor. So remember, your divisor is the value on the outside. So I'm going to write what's across the top. So 2g minus 2 plus our remainder, which we have is negative 5, over the divisor, which is 2g minus 3. All right, so now I just need to simplify, and by simplify, I mean just move the negative out to the front. So we're going to have 2g minus 2 minus 5 over 2g minus 3. All right. All right. So for the next one, now we have what we call zero coefficients. So you can't skip any exponent values. So if you look at the problem here, if you look at the dividend, notice how we go from an exponent of 3 to an exponent of 1. We completely skipped an exponent of 2. So when we're dividing polynomials using long division, we can't do that. So what that means is we actually have to give it a placeholder. So we need a placeholder with a coefficient of 0. All right, so I'm going to rewrite it so that it matches like this. So 18k cubed plus 0k squared minus 8k plus 2. So right here, this 0k squared, that's the placeholder. It's still the exact same expression as the original problem. We're just kind of filling in some gaps. All right, so this is what I'm going to take and use to divide. All right, so I'm dividing by 3k minus 1. All right. So the reason we're doing a placeholder is for combining like terms, which will be apparent in a few minutes. All right, so same idea. So 3k times what gives you 18k cubed? So I'm going to write it off to the side. So 3k times what gives you 18k cubed? So what that's going to be is 6k squared. So that 6k squared is what I'm going to write across the top to start the quotient. So 6k squared. All right. Now I want to multiply 6k squared times 3k minus 1. And I'm going to write it underneath right here. All right, so 6k squared times 3k is going to give me 18k cubed. And then 6k squared times negative 1 gives me negative 6k squared. So if you notice here, because of that placeholder, these x or these k squareds right here, they line up. If I didn't have that 0k squared placeholder, these values would be right here, and I'd have 8k over negative 6k squared. Those couldn't combine, they're not like terms. So I would be kind of at a stopgap right here, which means I have to have that placeholder. All right, so that's why we had that placeholder. All right, so now I'm gonna go through, and we have 0k squared minus negative 6k squared. So when you subtract a negative, that turns into a positive. So we have 6k squared. All right, so that's the first set. So now I got to do another round, or my next round. So I'm going to bring down this negative 8k. All right, so once again, we're looking at the leading term. So 3k times what gives you 6k squared. So I'm going to write that off over here to the side. 3k times what gives you 6k squared. All right, so that is going to be 2k. So 2k is what I'm going to write across the top here. So now I want to take 2k and multiply it times 3k minus 1. So I'm going to have 6k squared minus 2k. And then I want to subtract. So the 6k squareds, those are going to zero out. And then we're going to have negative 8k minus negative 2k. So it's going to turn into negative 8k plus 2k, which is negative 6k. So that's what's going to be written down here. All right. So we still have another value to bring down. So I have a whole other round of these that I got to do again. So plus 2. All right. So once again, 3k times what value gives you negative 6k? So 3k, oh, nope, wrong color. So 3k times a value, that gives you negative 6k. So that value is negative 2. All right, so negative 2 is what I write across the top. All right, so now I'm going to do negative 2 times 3k minus 1, and I'm going to write it underneath right here. So negative 2k, nope, negative 2 times 3k gives you negative 6k. The negative 2 times negative 1 gives you positive 2. So notice how we have the exact same binomial minus that exact same binomial, which means we're going to have a remainder of 0. So your final answer here, so we're going to have 6k squared plus 2k minus 2. All right. So my advice to you is to always write out some of those steps on the side. I don't typically require the steps on the side to be written, but I highly recommend it, especially for instances like this right here, where you're subtracting a negative. Those are the cases where people mess up all the time. And one small little misstep in these problems makes the whole thing fall apart. These are domino problems. If you mess up the very beginning, the rest of it falls with it. All right. Now for your last special case here. So we have high to low exponents. So you cannot go from a higher exponent to a lower exponent, which means you may have a remainder on these. All right, so I'll make this more apparent when we actually start solving it. Just gonna write it over here so I can just throw it over there. All right, so what I will say about these is the problems are shorter, much shorter. All right, so we are looking for the leading terms. So 4w squared times what gives you 20w squared. So that value is 5. All right, so I'm going to multiply 5 times 4w squared minus w and write it underneath. So I'm going to have 20w squared minus 5w. And then I'm going to subtract. All right, so notice how it's the same binomial minus the same binomial, which means it's going to be 0. So now I need to bring down this 4. So if you look here, we have an exponent of, or we have a degree of 2 here. But down here, we don't even have a variable here. We can't go from an exponent of 2 to an exponent of 0. We can't go from a higher power to a lower power. So that means we have to stop here, which means that 4 is going to be the remainder. So our answer here is going to be really similar to this process over here with the remainder. So I want the quotient plus the remainder over the divisor. So I have 5 plus 4 over 4w squared minus w. So this would be our final answer here. Okay. All right. So down here, this is just mixed practice. All right, so this is just kind of practicing what we just learned. So looking here, we have 8h squared minus 32h plus 16 divided by 2h. Now here, we're dividing by a monomial. That's your indicator here that we can just do our exponent rules. We don't have to do long division. All right, so I'm going to do 8h squared minus 32h plus 16. So every term of the dividend gets its own numerator. And then the divisor is written in every single denominator. All right, so now you just want to simplify from here. So we're going to have 8 over 2, h2 minus 1 minus 32 over 2. And these h's would just simplify out. And then you're going to have 16 over 2 and 1 over h. All right, so this is going to be 4h minus 16 plus 8 over h. All right. So for number 2, now we're doing a binomial. So this means we have to do long division. All right, so we're going to have r squared minus 5r plus 4. We're going to divide it by r minus 4. All right, so I'm going to start by doing r times what value gives you r squared. R times some value, which gives you r squared. So that value is going to be an r. So I'm going to write the r on the top. And now I want to do r times r minus 4. So we're going to have r squared minus 4r. All right, so underneath here, we're going to have negative 5r minus negative 4r. All right, so this is going to be negative 5 plus 4, which is just negative 1r. So I'm going to have negative r. Then I'm going to bring down this 4. All right, so once again, look at the leading term. So r times what value gives you negative r? So r times some value gives you a negative r. So that value is a negative 1. So I'm going to write that up here. Now I just want to write negative 1 times r minus 4, which is written down here. So we're going to have negative r plus 4, which is the exact same. So when we subtract, we have a remainder of 0. So our quotient here is r minus 1. All right, we're almost done, I promise. Okay, so looking at number 3. So if you look at your dividend here, your very first one, notice how we go from a power of 2 to a power of 0. So we're missing a term, which means we need a placeholder. All right, so I'm going to have 3x cubed minus 10x squared plus 0x plus 1. All right, then I'm going to divide by 3x minus 1. All right, so 3x times some value, which gives you 3x cubed. So that value is x squared. So that's what's going to be written up top. So now I'm going to do x squared times 3x minus 1. So 3x cubed minus x squared. All right, so now I'm going to do negative 10x minus negative x squared. So minus a negative turns into plus a positive. So we have negative 10x, should be a squared. Negative 10x squared plus x squared, which gives you negative 9x squared. All right, so that's the first set. Now I want to move on to the second set. So I'm going to bring down the 0x. All right, so I'm going to do 3x times some value to give me negative 9x squared. So 3x times some value to give me negative 9x squared. So this would be negative 3x. So that's going to be the next term. All right, so I'm going to multiply negative 3x times 3x minus 1. So we're going to have negative 9x squared plus 3x. And we're going to subtract. So negative 9x squared minus negative 9x squared zeroes out. So we have 0x minus 3x, which is negative 3x. All right, now I'm going to bring down that 1 for our final round. All right, so plus 1. All right, so 3x times what value gives you negative 3x? So 3x times some value to give you negative 3x, which means our value here is negative 1. So that's the last value up here. All right, so negative 1 times 3x minus 1. So negative 3x plus 1. Subtract, and we have a remainder of 0. All right, so our final quotient here is x squared minus 3x minus 1. That was a long one. All right. So for the next one, number 4. All right, so now if you notice here, it just needs to be reordered. All right, so I'm going to fix the order. So we're going to have 2b squared plus 16b plus 24. And that's divided by 2b plus 4. All right. So 2b squared plus 16b plus 24. And we're dividing by 2b plus 4. All right. So for this first step here, 2b times what gives you 2b squared? So 2b times what gives you 2b squared? So that would be just b. So I'm going to write that up top. And now I want to multiply 2b plus 4 times b. And I'm going to write that underneath right here. So I'm going to have 2b squared plus 4b. And then I'm going to subtract. So 2b squared minus 2b squared gives you 0. So then I'm going to do 16b minus 4b, which gives you 12b. All right. Now I'm going to bring down the 24. All right, so 2b times what value gives you 12b? So 2b times some value gives you 12b. So that value is going to be 6. So that 6 is what I'm going to write right up here. All right, so now I want to do 6 times 2b plus 4. Just going to give me 12b plus 24. So when I do my subtraction, we have the same binomials, which means we have no remainder. So our quotient here is b plus 6. All right, and then number 2. Okay, so looking here at number 5. So now instead of a trinomial, now we actually have a polynomial. So it's just 4 terms. So it really just makes the problem a little bit longer. It just adds an extra step. All right, so 12f cubed plus 8f squared minus 39f minus 20. All right, and then I'm going to divide by 6f minus 5. All right, so for the first step, so 6f times some value to give you 12f cubed. So that value would be 2f squared. Let's move this over a little bit. All right, so 2f squared is what I'm going to write across the top. So I'm going to multiply 2f squared times 6f minus 5. So 12f cubed minus 10f squared. And I'm going to subtract. So now I want to do 8f squared minus negative 10f squared. So it's going to be 8 plus 10f squared, which is going to give me 18f squared. So that's what I'm going to write here. Oh my gosh. All right, so that's the first step. Now for the second set, bring down the negative 39f. All right, so 6f times some value to give you 18f squared. So 6f times some value to give you 18f squared. And that's going to be 3f. All right, so 3f I write across the top. And now I'm going to do 3f times 6f minus 5. So I'm going to have 18f squared. And then 3f times negative 5, which is negative 15f. And then I'm going to subtract. All right, so here I'm going to have negative 39f minus negative 15f. So this is going to be a plus a positive. So negative 39 plus 15, which is going to give you negative 24f. All right, so that's what's going to be written here. All right, and for the last one, bring down the negative 20. All right, so same idea here. So 6f times what gives you negative 24f. So 6f times some value to give you negative 24f. So that value would be negative 4. So that's what I'm going to write across the top. All right. Now I'm going to multiply negative 4 times 6f minus 5. So you're going to get negative 24f. Then, nope. That gives you plus 20. Oh, shoot. This should be a plus 20. This right here should be a plus 20. That's what happened. Small fix. There we go. Now it'll zero out. So that's 0. There we go. All right. So your quotient here, so 2f squared plus 3f minus 4. There we go. Okay. We're having so much fun. I know we are. All right. Number 6. Tragically, this is the long one. All right. So we have a 1, 2, 3, 4, a 5-term polynomial. So 4n to the 4th minus 11n cubed plus 21n squared plus 50n plus 11. All right, we're dividing by 4n plus 1. All right, so started off with some orange. All right, so 4n times some value to give you 4n to the 4th. So 4n times some value to give you 4n to the 4th. So that value would be n cubed. So that's what I'm going to write here at the top to start it off. So n cubed, I'm going to multiply times 4n plus 1. So 4n to the 4th plus n cubed. And I'm going to subtract. So I have negative 11n cubed minus n cubed. So negative 11n cubed minus n cubed, which gives you negative 12n cubed. All right, so negative 12n cubed. So that's the first round. So I'm going to start the next round. I'm going to bring it down. So plus 21n squared. All right, so 4n times some value to give you negative 12n cubed. So 4n times some value to give you negative 12n cubed. So that would be negative 3n squared. So that's what I'm going to write up here. Negative 3n squared. All right, now I want to multiply. So negative 3n squared times 4n plus 1. You write it right here underneath. So we're going to have negative 12n cubed minus 3n squared. All right, so 21n squared minus negative 3n squared, which means I'm going to add these. So I'm going to have 24n squared. So 24n squared. All right. burrowing down. All right, so once again, 4n times some value to give you 24n squared. So 4n times some value to give you 24n squared, which that value is 6n. Why did I write m? It should be an n. There we go. All right, so now I'm going to write 6n across the top. All right, so now I'm going to do 6n times 4n plus 1. So that's going to give me 24n squared, then 6n times 1, which gives me 6n. And I'm going to subtract. So 50n minus 6n, which gives you 44n, which is what's written here. All right. Now I'm going to bring down this 11 for our final round. Because I know we're all just having so much fun right now. All right, so 4n times some value to give you 44n. This small little green is bothering me. There we go. All right, so 4n times some value to give you 44n. So that equals 11. So 11 is what I'm going to write across the top. All right, so now I'm going to do 11 times 4n plus 1, which gives me 44n plus 11. I subtract, which means no remainder. The beast has been defeated. All right, so your final quotient here is n cubed minus 3n squared plus 6n plus 11, I think. Yes. Boom. The evil has been defeated.